sure you're very excited about having another math extension class, but this one's kind of fun, so I think you'll enjoy it. We are going to, Mrs. LeBeau should have a piece of note paper for you today. I could think of nothing more applicable to your life than today's lesson about, ladies and gentlemen, percent of change. Why is that? Well, because this talks about when you go into stores and everybody loves a good sale, you know, how do you figure out what price you're going to pay for that? So let's talk about this a little bit here, okay? First of all, the number one thing you have to remember here is we will also be using percent boxes. Oh, I suppose I need to make this a little bit bigger so everybody can see it here. Now this should be your piece of paper like this, but so if you jot this down here on the bottom, you are going to do percent boxes. Make that a little bit bigger or no? Sure, why not? Percent boxes. But the deal with this is percent of change. So it adds a little bit of a little chink in the proverbial armor here. Percent of change deals with what we call marking things up, markups, and it deals with markdowns. Okay, markdowns typically, you know, stores, when you go to a store, if something's marked down, it is a sale. It's on sale. You get a special price for it. Markups we don't talk so much more about, but you have to understand that markups are how stores make their money. For example, you know, a store goes out and buys a pair of tennis shoes from Nike. It has to mark up the price so that it makes some sort of profit here. So this is an increase, while a sale is a decrease. And how it works is like this. Here's where things are a little different than what you're used to. We still do percent boxes, but this is what the percent boxes look like and are changed to. Okay, you do have your percents right here and then your actual right here. But back in the day, we would add our 2% up here and get a total. That's not how this works quite, because basically this, here's what you have. You have your original price, and then if it's a markup, you have to put a plus here, plus the increase, and then you're going to get your final price. Okay, if this is a markup, which makes sense because the price is going up, you're increasing it. Where maybe you can guess the next thing I'm going to say is if it is a percent decrease, the box looks the same. Sorry about my terrible box making ability here. The percent and actual, you start off with your original price, but it's a decrease, it's minus a percentage. And then you get your final percent, your final price right here. So this is a markdown. So when you read one of these problems, you have to decide, is it a markup or is it a markdown? So let's take a look at a couple. I threw four, well, I gave you a sheet with a bunch of examples, but let's look at the first one here. An item with a regular price, so that would be your original price, is discounted. Well, obviously, if something is discounted, it is a decrease, and it decreases by 30%, and then the sale price is your final price. So let's do this in some sort of, I'm going to do this. Give me 2 seconds here. I'm actually going to take this problem and put it on a new piece of, a new screen here. Give me 2 seconds here. Thanks for your patience. Appreciate it. Have a good day, blah, blah, blah. All right, so here's what this would look like. And I think you'll find this actually pretty simple here. This is a percent decrease. I start with my percent box. Our percent, our actual, our original price, our decrease or minus, and then our final price. So here we go. Let's fill in the proverbial blanks here. Okay, a regular price. Well, first of all, the original percent is always 100%. You don't have to be told that. That's just the way it is. The original is your starting, it's your 100%. Okay, we do know our percent decrease. Our percent decrease is 30%. And based on this, if you take 100 and decrease it by 30, your final price, you are actually paying 70% of the original price. You get to take away 30%. That means your 70% is what's left for you to pay. And then we have right here, the original price was $15. And you don't need to put a decimal there. You can just leave that as $15. And they want the sale price. So notice here, I don't need this part here. I just need the 4 that I have there. I'm going to rewrite it as a fraction. 100 over 70 has to equal 15 over what number? Now, you could simply just go attack it right now with cross multiplying and blah, 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 blah. Or you could reduce this fraction. Let's do that. If I take off ending zeros, which is dividing both of them by 10, I get 10 over 7. Let's just do that. You can't really do 10 times what is 15, so we're going to do our cross multiplying. 10 times n equals 7 times 15. That's these two. And maybe, ladies and gentlemen, you can do that in your head. I don't know. 7 times 15 is 105. 10 and equals that. And fortunately for you, dividing by 10 is pretty simple. You just move the decimal back one place. Your answer is 10.5. But we're talking about money here, so it's actually $10.50. So my sale price, if I mark $15 off by 30%, I end up paying $10.50. You know, if you wanted to know how much you saved, you would just subtract the $10.50 from 15, and you'd save what? $4.50 in savings. How about that? That sure was exciting, wasn't it? Somebody say, let's do another. Jacob, let's do another here. All right, where was my original screen? Sorry, I didn't want that. Let's go back here. Let's look up, let's do a markup problem here. I'm going to grab that second. Going to grab the second problem here, letter B, a shopkeeper. He's marking up his price. So here we go. And I know it's too big. So here's Mr. Shopkeeper. He buys an item for $25. And again, here is your original. This is the original price, $25. Marks up the price to $80. And hold on a second. Hey, Lynn, how are you? Sure, be there in a second. Yep, bye. All right, you may have to fast forward to these people. I'll be right back. All right, sounds great. Sorry about that. Let's go back to where we're at here. Hey, shopkeeper. All right, back to this. This is the original price. Here is the markup. This is what we have to add to our original percent. And we want the final price. So here we go in big letters. And I'm sure anytime you see this, you definitely will be drawing this. Here's the actual price, original price. It's a markup. So you have to push a plus and then your final price. So here we go. Let's fill in the blanks here. Original percent, always going to be 100%. Marks up 80%. So your final price is actually 180% of what it started out being. And that started out being price is $25. Again, you don't really need to put the decimal and the zeros in there because it'll all work out in the end. Just know in the end you need to change it back to money. And I am looking for the store price, which is this one right here. So 100, don't need this, over 180 equals 25 over what number? And again, you can kind of work this however you want. I always like to reduce this, make it easier numbers. If I divide this by 10, those zeros go away. Cut them both in half, I actually get 5 over 9. And this one works nicely because 5 times 5 is 25. So 9 times 5 is 45. And again, I'm looking for money here. So my final price is $45. Marks up 80%. What is the store price? $45. How about that? Maybe we'll do one more. Sale price. Let's do this increase in population one. Let's do this one here. Letter D. Letter D. Letter D. The town's population increased from boom, 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 boom. So this one, we're not given the percents, we're just given the numbers, ladies and gentlemen. But you have to understand, it started out being 80,000. So that's our original. It went to 90,000. That's our final number. And we need to figure out the percent of increase. So if we do our big old box here, we end up with this. Here's again our percents, our actual. This is our original percent. This is an increase, so you're going to be a plus. And this is your final number or final percent. Now notice what you're looking for is the percent of increase. This is what we're looking for. What percent did it go up? I always know my original percent is 100%. Here are my numbers. My original number is 80,000. My final number is 90,000. So you should, based on all your mathematical abilities, be able to figure out if it went from 80,000 to 90,000, how much did it go up? It went up 10,000. So this is all I need to know right here. I can make my little fractions, my equal proportions, equal ratios. 100 over what number equals 80,000 over 10,000. Okay. Now it's important to note you're looking for a percent in the end here. So whatever number you get is a percent of that. So let's do this. Again, if you can reduce fractions, I'm always up for that. Dividing them both by 1,000 would be by that. Dividing them both by 10 would give me that. So I end up with 8 times what number equals 100 times 1. So whatever I get when I divide 100 by 8 is going to be my answer, which is, looks like, yeah, 12.5%. The percent increase is 12.5%. So if you're looking for the final percentage, it would be 112.5%. That would be your answer there. Poof. We're going to, for tomorrow or for when we get back or for Tuesday of next week, I'm going to have you finish the rest of those problems, D through whatever is left there. What was it? Yeah, D through I, and see how you do with all that. So I am going to stop sharing and hope you have a great weekend. I'm going to close off this meeting. Sorry about that little interruption there, but you're young, you'll live. Thanks, 7th grade.